Okay, little radical equation we want to solve. Now the key, isolate the radical, well it already is in this one. So we've got the radical all by itself here on the left side of the equation equals p. What do you do to get rid of that radical? Well, square both sides. Of course, if this was a cube root or something, we would cube both sides. But we're going to focus on just square roots today. So if we square both sides, that radical goes away. So we've got 6 minus 5p equals p squared. Well, now we're ready to solve it. It's a quadratic. We're not done, but we did get rid of that radical. So let's get everything on the same side and solve this quadratic. So I'm going to bring these things over here. I'm going to flip it though, write this on this side just so my squared term's positive, not negative. So p squared plus 5p minus 6 equals 0. Again, I basically brought this stuff over, and then I just flipped the whole thing so I'd have things on the left side. Okay, you got a little quadratic. Here's your options. Factor, I think this one will factor nice for us. Of course, you can always complete the square, use the quadratic formula if you want. So factors of negative 6, so two numbers multiplied to make negative 6 that add to make 5. Well, 6 and negative 1 will do that. So p plus 6, p minus 1 equals 0. So p could be negative 6 or 1 if we just straight up solve that quadratic. Now, here's where you always need to check, though, when you're solving radical equations, because when you square both sides like that, you can introduce extraneous solutions. So let's go back to this original equation. Well, if I plug a negative 6 in, notice what would happen. You'd have some radical expression equals negative 6. Well, that's not going to be true. That's not going to work. 1. So 6 minus 5, that'd be 1. Square root of 1 equals 1. Hey, that works. So p equals 1 is a valid solution. So again, always want to check.